The SR-71 Blackbird, the world's fastest stealth spy plane. It flew faster than a rifle bullet. 3 times the speed of sound.
It looks like it's part spaceship, part airplane. And when you see it in the air, it's a piece of artwork.
Even now, 50 years later, it's still the fastest and highest man has ever flown without rocket propulsion.
The Blackbird is the iconic aircraft of high-speed supersonic cruise.
It was a multi-million-dollar gamble that stretched 60s aviation technology to the limits.
Incredibly forward-thinking design on this. No high-powered, computers, just rooms of people with slide rules and calculators.
The thing that's special about the Blackbird was it was all miracles.
Blackbird pilots risked their lives to fly at the edge of the possible.
It was just breathtaking when we realized what we were going to be doing.
These basically became sentinels, if you will, for the free world.
Its greatest legacy, helping maintain peace when the world was on the brink of nuclear war. January 1966. 2 ace test pilots prepare for a critical experimental flight. The plane they're about to fly is an ultra-fast covert military jet, and it's just been modified to maximize performance. In the cockpit is a pilot with 4,000 flying hours under his belt, Bill Weaver.
We took off about 11 something in the morning. We headed out on the program route. Everything was okay, routine.
Crazy altitude.
In the back seat is reconnaissance expert Jim Zweyer.
Copy that.
Flying at Mach 3.2, Weaver banks into a turn. And without warning, one of his engines stalls.
It's a very startling event. You could never prepare yourself for it. It was once described by one of the pilots as like being in a train wreck.
At over 3,000 miles an hour, the unbalanced plane is impossible to control. It pitches into a catastrophically steep climb.
I had to stick full left corner of the cockpit and no response to the airplane at all. I knew that we were just going to be along for the ride when that happened.
Inside 2 seconds, the plane starts to break up.
The airplane just basically disintegrated around us.
The quest to build the world's fastest spy plane is on the edge of disaster. The story of the SR-71 Blackbird begins 9 years earlier, at the height of the Cold War. In 1957, the Soviet Union develops intercontinental ballistic missiles.
Dear Khrushchev boasts that Russia already has intercontinental missiles in mass production.
The threat of a direct nuclear strike on US cities makes gathering intelligence on the Soviets' nuclear arsenal a top priority.
Well, in any conflict, knowledge is power. And we had to find out what the Soviet Union was doing, particularly with the missile program.
We had a vital need to understand the capabilities of the Soviet military machine, but the Soviet Union was so vast that we could not gain this by using conventional aircraft.
America needs specialist spy planes to fly reconnaissance missions deep into Soviet territory. Without being detected by radar and shot down by enemy jets. In late 1957, the CIA asks defense contractor Lockheed to come up with a new undetectable spy in the sky. They would call it Project Archangel, led by aviation genius Kelly Johnson.
Kelly Johnson undoubtedly is the Leonardo da Vinci of aviation design.
The difference in him and other airplane designers is he had a vision of the future and the art of the possible.
I had a great relationship with him. Yeah, I trusted him. He was almost a father figure to me.
Johnson had worked for Lockheed since 1933. He'd put together a small maverick design team just outside Los Angeles, nicknamed the Skunk Works. Johnson's team had designed several military planes, including a supersonic jet fighter, the iconic Lockheed F-104 Starfighter. By the late 50s, Skunk Works was at the top of its game.
The factor that makes the Skunk Works different than other airplane design organizations is that they assume it can be done and then figure out how to do it.
Back in 1955, Kelly Johnson had created America's first plane specifically designed for spying. The U-2 was a single-engine jet plane that could fly at altitudes of 20,000 meters, which according to US intelligence was 1,500 meters above the reach of Soviet radar.
The idea behind the U-2 was to fly so high that the very sophisticated Russian radars would not be able to detect it.
In 1956, the U-2 flew its first operational mission over Soviet territory. It returned safely with valuable intelligence. But the onboard device the plane carried to detect radar waves delivered some bad news. Soviet radar had tracked its every move.
From our estimates, if the U-2 were to fly above a certain altitude, it could not be detected. The problem is we were wrong. The Soviet radars were better than we thought they were.
The only comfort was that the Soviets had no means of downing the U-2 at this altitude. Yet. The Skunk Works team knew it was only a matter of time before Russian missile technology would catch up, with disastrous consequences. They would have to deliver the new undetectable spy in the sky, and fast. "50 years after it was built, the SR-71 Blackbird still holds the record as the world's fastest manned plane using air-breathing engines.
The amazing thing about the Blackbird is that it instills emotion in anyone, not just airplane enthusiasts. It looks like it's part spaceship, part airplane. And when you see it in the air, it's a piece of artwork.
Even more extraordinary, it pioneered the idea of stealth technology, with a design that was almost impossible for enemy radar to detect. But reaching this pinnacle of aviation technology wasn't easy. In the spring of 1958, Skunk Works starts work on Project Archangel. the CIA's top-secret plan to replace the vulnerable U-2 spy plane. Kelly Johnson knows the new design will have to fly much higher than its predecessor to evade advancing Soviet radar systems. And also much faster to get out of trouble even if detected.
As the missile threat evolved, speed now became very, very important. And so if you have a fast-moving target that may be also turning or maneuvering itself, it poses a very difficult challenge to an intercepting missile.
But the CIA wants more. The order for a new super spy plane had come from President Eisenhower himself. And he wants it to be invisible to radar. Achieving radar invisibility seemed near impossible. When radio waves from a radar transmitter strike a plane's circular fuselage, they scatter in many directions, producing an obvious and distinctive radar signature. Reducing this signature will require nothing less than a radical rethink of aviation design. Yet, in 1958, the idea of such stealth technology is in its infancy. And delivering it, alongside high altitude and high speed, will test Skunk Works' abilities to the limits.
The Skunk Works team began looking at designs to meet these requirements of higher than 80,000 feet, faster than 2,000 miles per hour, as well as being reduced in radar cross-section.
Over 11 months, Skunk Works engineers draft 10 designs, each prefaced with the letter A for Archangel. Some aim for a reduced radar signature, others to achieve speed or height. None manage all three. The front runner is the A-10, capable of flying far higher than the U-2 and at over 3 times the speed of sound, Mach 3.2. But performance comes at a price. Its shape will make it highly visible to radar. In March 1959, things become critical at a meeting with the CIA's head of black operations. Kelly Johnson argues that the A-10 is the best design, despite its radar visibility. Designed to fly so high and so fast that even if detected, the Soviets will have no time to react.
There was always a debate from the time of the U-2 onwards about which was the best way to defend a high-altitude reconnaissance aircraft.
The CIA knows the president isn't about to settle for speed over stealth. It looks like the end of the road for Project Archangel. On the brink of losing the contract, Skunk Works throw themselves at the radar visibility problem one last time.
The M Lab was trying to come up with the answer for that. Yeah, we spent a lot of time and money trying to develop stealth.
The challenge? To modify the plane's profile without compromising performance. 2 months later, one of the engineers makes a breakthrough. He takes the existing design and adds elements from other Project Archangel designs that reduce radar signature. The result is a radical new, streamlined look. The new design has a flatter underbelly and sleeker lines. When radio waves encounter this plane, instead of bouncing back to enemy radar receivers, they should deflect harmlessly away, along the flattened fuselage. The result? An incredible 90% reduction in the radar cross-section.
The radar cross-section was something like 10 meters. You know, that's a big eagle, or it's a very small airplane.
Now, the new spy plane faces the ultimate test. Will it convince the CIA? Kelly Johnson tells the agency the new plane will fly 8 kilometers higher than the U-2, at 3 times the speed of sound, and all the while presenting the radar profile of a large bird. On February 11th, 1960, the CIA approves a $96 million contract for Skunk Works to build a dozen spy planes, now called the A-12. There is no time to waste, because just 3 months into the project, disaster strikes. On May 1st, 1960, a U-2 spy plane is shot down by a missile in Soviet airspace. The pilot, Francis Gary Powers, survives. He is put on trial in Moscow and paraded in front of the media, together with his once top-secret spy plane. It's an ominous sign of how fast Soviet technology is developing. Because Powers' plane had been downed by a state-of-the-art radar-guided surface-to-air missile, the Dvina SA-2.
We knew the U-2 was going to be very limited from that point on in terms of random overflying anywhere in the country. So in that sense, the technology of the other countries were catching up to us.
More than ever, the United States needs a spy plane that can't be shot down. Skunk Works feels the pressure. Building a plane with the futuristic qualities they'd promised the CIA is a monumental challenge. The downing of a U-2 spy plane by the Soviets in 1960 increases the pressure on Skunk Works to deliver its futuristic replacement. The new plane is supposed to cruise at a record-breaking Mach 3. But flying at 3 times the speed of sound throws up some fundamental problems. First, a conventional aluminium airframe is out of the question. Because at over 3,000 kilometers an hour, the friction created by airflow alone will heat the airframe to over 300 degrees Celsius. Skunk Works knows aluminium loses its strength at 150 degrees, which for a Mach 3 airplane is barely breaking a sweat.
There were places on the Blackbird that were 600, 700 degrees Fahrenheit. Your oven at home goes to 550 degrees Fahrenheit. And so you had to look for materials that could survive those kinds of temperatures.
And that's not all. To reach high altitudes, an airframe has to be light. But to fly supersonic, it must also be robust. There is only one material that meets all the demands: titanium. But the leading producer of the rare metal is the Soviet Union.
The trick of how do you acquire the titanium and the volume necessary while not giving away the fact that you were building something like the Blackbird was a security challenge.
The titanium is bought through dummy companies, so that the Soviets don't realize their customer is the CIA. But working with it is uncharted territory.
So how do you machine it? How do you form it? How do you assemble it? A lot of that had to be created on the fly.
Titanium is so hard that it damages standard machining equipment, forcing Skunk Works to develop new manufacturing processes. "300-degree temperatures pose another problem. Metal expands when hot. To ensure the plane's panels fit together tightly when flying supersonic, they need to fit loosely while on the ground. No big deal, except when it comes to the fuel tanks.
There's no internal bladder tanks. There's no internal metal tanks. The skin of the airplane is the tank.
As a result, it was a leaky airplane. You would see this aircraft sitting on the ground with a puddle of fuel under it.
Traditional aviation fuel is highly volatile and liable to explode at the high temperatures generated in flight. So Skunk Works asked Shell to develop a brand new fuel, an exotic mix of hydrocarbons and lubricants with exceptionally low volatility, which they call JP7.
I've seen the crew chiefs throw cigarette butts and matches. It extinguishes, it won't catch on fire.
This is just one of many ingenious solutions that Johnson's team devises to overcome a string of engineering challenges.
Kelly wanted the simplest answer you could have. One of his rules was one miracle per program. The thing that's special about the Blackbird was it was all miracles.
By the spring of 1962, people in Arizona begin to see strange craft streaking through the skies near the top-secret Area 51. It's the latest version of the Skunk Works A-12 spy plane. The sightings fuel talk of UFOs.
And so you start seeing bar talk develop. You start seeing people reporting what's going on. And in some cases, they're met by people in suits who take them away and tell them, don't talk about what you saw.
2 years later, Skunk Works believe they've made an even better version of the plane, a two-seater. And in 1964, the government decides to scotch the rumors of UFOs and unveil it. The new spy plane, destined for the US Air Force, will be called Reconnaissance Strike, RS-71. But the speech by President Johnson doesn't go as planned.
I would like to announce the successful development of a major new strategic manned aircraft system. This system employs the new SR-71 aircraft and provides a long-range...
When President Johnson announced it, he got the designation backwards. It should have been RS-71, but he said SR-71, and it sounds better, and the name stuck.
The Joint Chiefs of Staff...
The Air Force decide it's easier to rename the aircraft than to correct the president's error.
And of course, no one wished to contradict the president, so from that point on, SR-71 it was.
Now, the entire world knows the SR-71 has put America back in the aerial spying game. It's time to put the SR-71 through its paces. December 22nd, 1964. A Blackbird completes its final flight checks at Lockheed's Plant 42 in Palmdale, California. It is the first official test flight of the SR-71. Test pilot Bob Gilliland has the dangerous privilege of being first in the cockpit. He has been handpicked by Kelly Johnson himself.
One glance and you could see it was high and fast and big and long. There were a whole lot of guys around the world that would like to have been in my position, but I was in the one that Kelly wanted to do it with, and so that's a hell of a high honor for me, and maybe perhaps my highest honor of all.
Every test flight has what are called open items, unresolved technical issues. But on this day, Gilliland knew there were 383 of them. Initially, Kelly Johnson and Gilliland agree not to push the plane too hard.
Kelly had said it's considered a successful flight if we just take off, leave the landing gear down, fly around and come back in and land. But then he says to me, how do you feel about going supersonic on the first flight? So I said, I have great confidence in our escape system here, so it's okay with me.
Gilliland's test flight breaks the sound barrier, reaching speeds of 1,600 kilometers an hour, cruising at 15,000 meters, over 3 kilometers higher than a commercial jetliner. But extreme performance demands extreme concentration. The tiniest error can spell disaster.
The pilots referred to the Blackbird as being a 3-second airplane. Every 3 seconds, you had to look at the instruments and make sure everything was working the way it was supposed to.
I got on down there for landing, and Kelly says, how's your fuel state? I said, excellent. So he says, well, how about a flyby? So we did a flyby.
The first flight is a great success. The Blackbird program is airborne. But the flight tests are about to face setback and tragedy. In January 1966, a crucial test flight for the Blackbird SR-71 spy plane is about to run into trouble. On board are pilot Bill Weaver and reconnaissance specialist Jim Zweyer. 24,000 meters up after losing control at Mach 3. The plane starts to disintegrate. At Edwards Air Force Base, Weaver and Zweyer's Blackbird disappears from the tracking radar. Both crew members are presumed dead. Fellow test pilot Bob Gilliland is on the base when he hears the news.
I found out it was Bill Weaver, and his locker was near mine, and there were 2 cigars.
Gilliland takes one of his friend's cigars to smoke in his memory.
I said, well, he may be dead, and if he is, I'll get him another. I gave him a whole box of cigars.
But Bill Weaver isn't dead. He had been free falling from the very edge of space.
I thought I was having a terrible dream, nightmare. And then I realized I wasn't dreaming, so I must be dead. And then I realized that I'm not dead, and somehow I'm out of the airplane. I could feel myself falling. I could hear the rushing of air.
Weaver doesn't know if his parachute is still attached until it springs open. Now his thoughts turn to his flying mate, Jim Zweyer.
Jim Zweyer's parachute looked like it was about a quarter mile away. That was really a relief. I didn't think either one of us was going to survive, but to think that both of us had was tremendous relief.
Weaver lands in New Mexico, 1,200 kilometers from the base. On the ground, he learns the sad news. His friend Jim has not survived after all. His neck broken. He had died the instant the plane disintegrated.
Find out that he had died, it was really devastating. He was a wonderful guy. He was one of the best.
An investigation found that optimizing the plane's performance had made it less stable. That led to a loss of control, which put the airframe under catastrophic strain. At the base, a call comes through to the accident investigation chief.
He says, yes, I will take a collect call from Mr. Bill Weaver. and then I heard that, and I knew he'd survived, so I was real thrilled at that. I told him I was going to get the Castro's best cigars I could find. I don't know, but naturally I would do anything for him.
He said he was going to get me expensive replacements, and I haven't gotten them yet. That was 1966.
By 1967, Skunk Works finds solutions to all the Blackbird's design problems. The planes go fully operational from Beale Air Force Base, California. Now, America just needs the men to fly them. A new group of elite pilots is assembled to join the 9th Strategic Reconnaissance Wing. They are the best of the best.
None of us had ever seen the airplane. And you can't imagine what that felt like to see that airplane come in. It was just breathtaking when we realized what we were going to be doing.
The Blackbird doesn't so much break records as shatter them. It can fly at 3 times the speed of sound, faster than a rifle bullet.
It was kind of a good feeling to know that anytime you were flying, you were going higher and faster than any other person in the world.
Its engines are the most powerful of the time, producing 160,000 horsepower. And swallowing 3,000 cubic meters of air every second, equivalent to 2 million people inhaling at once.
You've got so much power, it's smooth, it's quiet, it's just delightful.
It can fly an astonishing 25 kilometers above the Earth, applying a navigation system that used the stars to work out its position.
I mean, it's the world's biggest planetarium show.
You can see the curvature of the Earth. You can see almost 350 miles in any direction.
Unbelievable what you see at 80,000 feet or higher. Just fantastic.
Ironically, the Blackbird will never see active service over the Soviet Union, the role for which it was designed. But within a year, it will be called to operate in the heat of battle. March 1968, Vietnam. A daunting theater of war for the Blackbird's first combat mission. Its objective? To find an enemy Viet Cong site deep in the jungle, a supply area used to mount the siege of US Marines at Khe Sanh. The Blackbird delivers. Its high-resolution ground mapping radar reveals the secret site, enabling B-52 bombers to attack, ending the siege. The Blackbird goes on to give the intelligence community critical photographic and ground mapping data from all over the world.
Then you come back, and the intelligence community is just on it like ants on sugar. Okay, what has changed? Have they brought in some new defensive system, or what are we seeing here that's different from the last time we flew an area?
The SR-71 then went on to become the nation's premier reconnaissance system for keeping track of international crises. Whether it was the 1973 Arab-Israeli War, watching the Soviet fleet and its movements. We had SR-71s deployed to the Far East, operating out of Kadena. These basically became sentinels for the free world. Tremendous contributions of technical intelligence.
But the Blackbird is no longer invisible. In 1968, it is tracked by enemy radar for the first time. And as surface-to-air missiles grow ever more effective, Blackbird crews will soon face a direct attack. August 26, 1981, North Korea. The communist regime of Kim Il-sung is flexing its military muscles. Fearing an invasion of the democratic South, the West desperately needs intelligence.
We had to understand what is happening with the North Korean order of battle. What is their intention? Where are their forces? What are they up to? What are they doing? And there was only one system that could furnish that information, and it was the SR-71.
17 years after its first flight, the Blackbird is still the world's best spy plane. Now, it'll fly secret missions to locate the North Koreans' anti-aircraft missiles.
Okay, just leveling out. No problem, Skip.
Pilot Maury Rosenberg is tasked with flying over the DMZ, a demilitarized zone between North and South, but one known to be within reach of enemy missiles.
This aircraft, though, even on a training flight, let alone an operational flight, you never really relax. You're always watching everything. And the next few seconds, I could tell it was rapidly climbing.
August 1981, and in the midst of renewed hostilities, North Korea has fired a Soviet-made guided missile at a Blackbird spy plane.
Okay, I see it visual.
Less than 1 minute to impact.
It's climbing.
The window to shoot the missile and the missile to get to us is less than about 50 seconds. And it said, let's turn off track. And I said, okay, so we started to turn towards the left. Obviously, we didn't want to go right into North Korea.
The Blackbird is saved by its speed. The enemy just don't have time to recalculate the target coordinates and redirect the missile.
I saw the missile go by on the right side and explode. It's hard to judge distance at altitude because there's no reference. So I'm guessing that the missile was probably within a mile and a half of the aircraft.
I was a little close.
At Mach 3, that's equivalent to just 2 seconds from impact.
I actually felt pretty relieved when we got on the ground that nothing else happened.
Just as Kelly Johnson had predicted, even when it is detected, the Blackbird proves just too fast to catch. The Soviets even developed the MiG-25 jet fighter to bring it down. But not a single SR-71 is ever lost to enemy fire. An unmatched record.
There was really no weapon system that we knew of that could touch the Blackbird.
9 years later, and the Blackbird is still the world's fastest spy plane. But now, a new technology is taking over its role. Satellites are considered to be the future of intelligence gathering. In March 1990, the Blackbird program is shut down. On its final flight before retirement, the Blackbird creates a speed record that is still unbroken. It flies from Los Angeles to Washington, D.C. in just 1 hour, 4 minutes, and 20 seconds. It's a poignant moment for everyone in the program, and for some, difficult to comprehend.
There were many of us, myself included, that believed that the retirement of the Blackbird was premature. Just months after the program was canceled, Saddam Hussein invaded Kuwait, and the system that we really needed on hand immediately to find out what was going on was the Blackbird.
Today, the Blackbird's stealth technologies live on. The B-2 stealth bomber and Lockheed's stealth ground attack F-117A Nighthawk use the same kind of radar-diffusing black paint as that pioneered on the SR-71. 5 decades after it was built, the SR-71 Blackbird is still one of the world's most iconic planes. It has even appeared in Hollywood movies like Transformers and X-Men. To this day, it's the fastest and highest flying manned airplane that's not rocket-powered.
The Blackbird was revolutionary because it was the first aircraft designed for sustained flight at 2,000 miles per hour. It was the first stealth airplane ever designed. Everything about the Blackbird was special because of what the engineers asked it to do.
It has come to epitomize the perseverance, ingenuity, and patriotism of the men and women who built it, and of those who flew it in the service of 6 presidents.
It's an airplane that could make a statement. You know, you can't get us. We're here. We're watching you.
The Blackbird proved what we can do when we rise to conquer an impossible challenge.
I think one of the lessons of the SR-71 is you give men and women a task and give them the authority and the resources. It's amazing what you can create.
But perhaps the Blackbird's greatest legacy is as the aircraft that helped maintain peace when the world was on the brink of nuclear war.
This was the fastest airplane ever built. It helped win the Cold War, and that ought to be a pretty good little achievement.